Welcome to the lab. Today we're going to explore Ohm's law, or the relation between the voltage in the resistor and the current in circuit. You already know that in a closed circuit with a battery and a bulb, there's a flow of current that makes the light bulb glow. If you want to model this physical phenomenon, we can think of electrical charges, free charges, that are moving in the conductor in the wires. When the circuit is closed and an electric field is created in the conductor, this electric field will apply a force on the charges that will accelerate them. The conductor has free charges, but also ions that are fixed in space. The charges will collide with the ions, making these charges to stop and need to be accelerated again. Because these collisions will need the circuit to be closed all the time, we can think of these collisions as a resistance that circuit has to the flow of charges. Of course, depending on the device you connect to the circuit, this resistance will be higher or smaller. We can quantify this resistance as R, which we measure in ohms. In the circuit, the amount of energy available for the charges to accelerate is related to the voltage between the starting point and the end point of the circuit. This is between the positive and negative ends of the battery. There's a relationship between the current or flow, the resistance, and the voltage given by V is equal to IR, where V is the voltage measured in volts, I is the current measured in amps, and R is the resistance measured in ohms. We'll refer to this expression as Ohm's law. For example, if you have a resistor like this one in a closed circuit where there is a current flow, the voltage across the resistance is equal to the current through the resistance multiplied by the magnitude of that particular resistance. This applies to every resistor. For example, you can have two resistors in series. Then the voltage drop across the first resistor equals the current flow and the magnitude of that resistor, and the same happens for resistor number 2. Now, to test Ohm's law, you are going to set two resistors in series, one of which you know its magnitude, but not the other one. You will be measuring the voltage across the known resistor and the current through that circuit. So, you will have a value of voltage and a value of current. In order to determine the value of the unknown resistor and also the unknown battery, you will repeat the same setup, changing the known resistor several times. This way, you will have several values that will allow you to determine the unknowns with more precision from a plot. You need to write Ohm's law for the whole system. Then, you need to make a plot with the two measured variables and figure out how to determine R and V0. And may the science be with you.